Alright, hello everybody. We're in section 1.5 and we're going to solve some inequalities. So here's some directions, solve and graph, and we've got, this would be called a linear inequality. Linear because we have x to the first power, and this is our important rule. The only change is, if you multiply or divide by a negative number, you've got to flip the inequality. Otherwise, it's the same thing as if you were solving a linear equation. So I want to get this x by itself. First thing I'm going to do is move the 3 over, and whatever I do to one side, I do to the other. And 5 take away 3 is 2. And here we don't flip because we're subtracting. It's only when you're multiplying or dividing. Last step, here I'm dividing by minus 2. And here I'm going to flip because I'm dividing by a negative number. So x is greater than or equal to minus 1. Okay, to graph this, we draw a number line. Put down minus 1. Okay, since this is greater than are closed in circles. And I always think, okay, the alligator here is towards the x, so x is greater than or equal to minus 1, so I want stuff to the right. So this would be our graph. Everything from here over, and the interval notation would be closed in circles are always brackets, so bracket minus 1 to infinity. The infinities are always open. That would give us this whole solution space. Solution, graph, interval notation. Alright, let's take a look at another one. Alright, let's see if we can solve this. So this would be called a compound inequality because you've got two inequalities here, and I'm going to change this to make this less than or equal to. Okay, the goal here, we need to get x by itself. And now I just have 3 sides. Remember, whatever you do to one side, you got to do to all 3. So first I'm going to clear all fractions, multiply everything I see by 4. Okay, this is minus 12. I don't flip this because I was just multiplying by a positive number, not a negative. Here they cancel. I get 2x minus 1. And here I get 0. Okay, I'm going to add 1 to all sides. This gives me minus 11 is less than 2x. It's less than or equal to 1. And I'm going to divide everything by 2. And I get minus 11 halves is less than x. It's less than or equal to 1 half. And this is our nice solution. These fractions are okay because they're simplified. Doesn't matter if this is an improper one. And let's take a look at the graph. Okay, I gave myself some room there, so oops, still less than. Okay, here's our number line. Here's minus 11 halves is over here. And here's 1 half to the right. Let's see, minus 11 halves is less than x, so that should be an open circle. And at 1 half is x is less than or equal to 1 half, so this is closed. And we want what between them? So x's have to be greater than this, but less than this. And our interval notation would be parenthesis, minus 11 halves, comma 1 half, bracket. Closed in circles are bracket, open circles are parentheses. And infinities are always parentheses. Okay, let's take a look at one more. Alright, let's try to solve this. So I have parenthesis, 2x plus 4 parentheses to the minus first, and I want that to be greater than 0. Alright, negative exponents. Well, as you all know now, that moves to the bottom. And we're to there. Okay, the question is, on this left-hand side here, you have some kind of like fraction field. And we want to know, when is this fraction greater than 0? Well, fractions are greater than 0 when the top is positive and the bottom is positive, or the top is negative and the bottom is negative. And since this top is always positive, all we need is for the bottom to be positive, and then overall the whole fraction will be. So that's why we can just take a look at this bottom. As long as the bottom ends up being a positive number, which in this case happens when x is greater than minus 2, this whole thing will be greater than or equal to 0. Number line. Here's minus 2, it's open. I want stuff to the right. And the interval notation would be parenthesis minus 2, positive infinity. And that's inequalities. And that'll do it for this video.